algebraic fractions are fractions that have unknown variables, either in the numerator or in the denominator or both. So simplification of fractions, algebraic fractions, the aspect we are starting with is lowest terms. Like we used to do in common fractions. If I have a fraction like 4 over 6, this fraction is not yet in its lowest term because there is a number that divides both 4 and 6. And that number, we call it the common factor of 4 and 6. Highest common factor of 4 and 6. So once you have the highest common factor that can divide into the numerator and the denominator, you have to use that highest common factor to divide the numerator and the denominator so that the result is a number that nothing can divide again. So that result that nothing can divide the numerator and the denominator is called the lowest term of that fraction. So in this case, 2 can divide into 4, and we have 2. 2 into 6 is 3. Nothing divides into 2 and 3, which means this fraction is in its lowest term. So like we have it in common fraction, we also have it in algebraic fractions. So in algebraic fraction, if there's a variable that is common to the numerator and the denominator, you can divide through by that variable so that the result is a fraction that nothing is common to the numerator and the denominator. It is that one that nothing is common to them that you call the lowest term of the algebraic fractions. The same step we use in reducing a common fraction to lowest term is the same step we are going to use in reducing algebraic fractions to lowest term. So we have the first example here. It says reduce the following algebraic fractions to their lowest terms. The first one says xyz over yxz. So to reduce this to its lowest term, we look for a variable that divides both the numerator and the denominator. In other words, a variable that is common to both the numerator and the denominator. In the numerator, we have x here. We also have it there in the denominator. You have z here. You have it here also in the denominator. So both of them divide out. X divided by x is 1. Z divided by z is 1. And 1 times y is y. And 1 times w is w. So this fraction is its lowest term is y over w. That is question A. Then question B, I have u cube minus u cube v rather minus 3u square v square over 3u v cube minus u square v square. Okay, since we have an operation in between the terms, the operation is the operation of subtraction. So what we are going to do first of all is to factorize the numerator, and we also factorize the denominator. And to factorize means you look for a common factor, something that can divide into this first term, which is u to the power of 3v, and that thing we also divide into this second term without a remainder. That is what we mean by common factor. So I have u cube here, I have u square here, which means u square is a common factor since if I divide this u cube by u square, there won't be any remainder. So u square is a common factor there. The same thing, I have v here and I have v square here. So v is a common factor. V can divide into this term without a remainder, and you can divide into this term without a remainder. So bringing out the common factor, then we have, if I divide this u cube v divided by this, I will be left with only u there. That is the meaning of factorization. So once you bring out the common factor, it's like dividing this term by that common factor, so that u cube v divided by u square v, this v will cancel this v. Then I have up to 3u here, I have 2 here. If I cancel 2 out of this, I'll be left with 1. That is the 1 there. Then minus, if I divide this 3u square v square by u square v, I have v square there, that is 2 of them. So if I cancel 1, I'll be left with 1v. Then this u square will cancel this u square, which means I am left with 3 times v, which is 3v there. 3v. Then we do the same thing to the denominator. What is common to the denominator? We have u here, we have u square here, meaning u is common. U, then we have v cube here, we have v square here, so v square is common. And into 3, if we divide this by u, this u will be gone, and we divide by v square, we'll be left with only one v there. So 3v minus, if you divide this u square v square by u v square, one of the u will cancel, then the v square will cancel. So we have u only there. So with that, so this will be, now this u will cancel one u here. So I will be left with only one u there. Same thing, v will cancel one of the v there. So I will be left with v. So I'll have u into u minus 3v over v into 3v minus u. Now looking at this one is u minus 3v, and this is v minus 3v minus u. Now we can reverse this denominator as we rearrange it like this. I have u into u minus 3v all over v into minus u plus 3v. So that if I multiply the denominator through by 1, negative 1, then I'll have u into u minus 3v all over minus v into u minus 3v, so that this u minus 3v can cancel out. So that our answer now become u divided by v minus v is minus u over v. And that is for exercise.